So this is our industrial IoT network. We've got 5 different industrial nodes here, all of them M4 microcontrollers, and they're running Zephyr-based firmware. So Zephyr is an open source RTOS that kind of allows us to have one project file, but still use different hardware fairly easily. You can swap out the hardware on the software side very simply. Then we're taking some sensor data from these temperature sensors. We're putting it into MQTT. We're putting that into TLS. We're sending that down from the microcontroller via SPI to our 8M2111. That's a T1L Mac PHY.
Oh, so that's actually the PHY interface.
Yep. So there's switch fabric. Sorry, go ahead.
So what is the new Ethernet standard name that you mentioned?
It's 10 base T1L. So it's
10
an
base
IEEE standard.
And what is the speed?
That's 10 megabits.
And when did IEEE standardize it? Like
a couple of years ago. I don't remember the exact date that it was released.
But is it a mature standard now, or kind of a stable one?
Yes.
Okay.
So and they're still adding to it. So they've added recently SPoE. So we're very familiar maybe in Ethernet with PoE. But SPoE is single pair Ethernet, power over Ethernet.
Okay.
And with the right cable and the right classing, you can get up to 52 watts. So 52 watts of power. Now it's not at those distances, right? Obviously, you still have your IR drop. We can't beat physics. But with single pair Ethernet SPoE, you can get, with the right cable, the right distances, up to 52 watts of power delivery.
52 watts of power delivery.
Now it's not the point, but...
And you also mentioned 1 kilometer of length.
Yeah, so those are separate, right? Like the data side can go up to the spec for the data side can go up to a kilometer as long as your cable meets the insertion and return loss requirements. The power with SPoE, your power is obviously a lot more limited by your length, just because of IR drop inherent in the cable. But it's still, particularly for distances where you're not going crazy far, but you're just trying to deliver power on a single pair, it can be really helpful. And that is also an IEEE standard, right? It's not engineered power solution, it's standardized. It uses a PSE and a PD, just like you would think of with normal Ethernet PoE.
Interesting.
The other standard that we're not showing here...
So one question. So we're not talking about the electrical levels on the cable, okay? But we're talking about in 1 kilometer, your data rate it may come down a little bit, but you're promising like maximum of 10 gigabits per second.
No, 10 megabit.
10 megabit. Okay.
10 megabit is very different.
Okay.
Yeah.
That's okay. Correct me. So 10 megabit for 1 kilometer is possibly conceivable.
Oh yeah, it's doable.
It's doable.
Yeah.
Okay. Fantastic.
So, I mean, again, it depends on your cable. Like if you try and run it over doorbell wire, not going to work. But with the correct cable, you can absolutely hit those lengths.
Fantastic. Okay. So I was like, okay, so with 10 megabits on 1 kilometer, it's like a wow.
Yeah. That'd be pretty incredible.
I know, incredible.
And IEEE is of course working on other standards that build off of T1L that might go faster, but those are early stages, right? They're not released.
So just as a disclosure, so we are as a technology holding company.
Sure.
So we have started an initiative for a new aerospace bus standard.
Okay.
And we're trying to include a different consortium. There's a specific body for semiconductor liaisons, so who will implement. So we actually see CAN bus, time-sensitive Ethernet, and the ancient, the existing avionics bus standards pretty problematic, and there is actually a need for a reliable, low-speed delivery, but something that actually works.
Yeah.
There have been instances. I mean, there are real crash incidents because the bus performed badly.
Sure, they can get the data needed.
So, there is an UK-based flying car company, which are vertical takeoff and landing those electric VTOL vehicles. So they had a CAN interface from the autopilot or the central computer to all these thrust units, the motors basically. So the bus failure has caused deadly crash, and it's no joke. So it's like if you're interested, probably I'll set someone in touch with you, and we can work together.
Sure, it's interesting.
Yeah, fantastic. And this is fascinating. So it's 10 megabits per second.
Yep. Yep, and it's
yeah, it need not necessarily be a twisted pair.
So it should be a twisted pair, like for obviously for noise immunity, but you can definitely run it on non-twisted pair. It's just you're gonna get better performance if you have twisted pair. Yeah, and in this case, the 182111 lets you. This chip has two PHYs, so two T1L PHYs, and then the SPI port up to the microcontroller. There's a MAC table on there that lets you configure what frames you want forwarded versus not. And it allows you to treat T1L as though it were kind of a multi-drop network.
So the chip implements how many layers of the network? So it's just the PHY? Or?
So it's up to layer 2
because
you're doing MAC filtering, right?
Okay.
So that layer 2 helps forward frames.
Okay.
But yeah, it's the physical layer and then layer 2. And when you think about T1L and its sister single pair Ethernet T1S, it's really just a physical layer difference, right? Layer 2 and above is just like you and I would think of normal 100 megabit, gigabit Ethernet today. That's all the same. And so that's one of the benefits of single pair Ethernet. You can reuse all the resources you're already working on. You can leverage MQTT and TLS and all these other standards that already exist, libraries that already exist, right? It helps you get to end product a lot faster. And
Fantastic.
Develop your own, solution. And I mentioned T1S. 10-base T1S it did an additional IEEE standard, and instead of being focused on long point-to-point, it's focused on short multi-drop. So T1L is for long, T1S is short, and so you can connect multiple nodes together in a multi-drop situation. The number of nodes is a little limited. The standard says 8. You can get more depending on how things, depending on the network itself. But it can be a great solution for people that are looking for cabinet backplanes, or people that are building automotive solutions where the cable path is known and the number of nodes is known. So there are a lot, and again, that's also 10 megabit, and T1S is just multi-drop, shorter lengths. T1L point to point.